Today, let's talk about how do you program and wire a 4-pin button in CircuitPython. So wiring up a 4-pin button is pretty easy. We are going to wire our button in pull-up mode as opposed to pull-down, because pull-up tends to be a little bit more reliable for electrical connections and for reading our sensor. So we need a 4-pin button, we need a 10,000 ohm resistor, and then we'll need some male-to-male jumper wires as well as our breadboard. Now, if you look at the bottom of the bottom of the button has these two little knobs on it. This is so that you can keep it inside the bridge of our breadboard, because if you look inside our breadboard, we've got a little notch on the inside in the middle. So in order to push our button in, we have to be able to light it up so that those little knobs are on that bridge and push it down. Now, how a 4-pin button works is you have two lanes here. And these lanes are connected, and the lanes on this side are connected. And when you push the button, you connect and bridge the two lanes together. So these ones are totally independent until you press the button, then you put all 4 lanes together. So I'm going to line up so my little knobs are pushed in the middle, and if I push down, I should really seat that button in. I should be able to wiggle and move it. Oftentimes people don't read buttons properly because you just simply didn't push it in hard enough. Now we get some power over to our button. So let's grab our 3.3 volt system over here. I'm going to run it to the main power rail on my breadboard. I'm going to do the same thing with ground. I'll run it over to my main ground rail. Now, because we're wiring this in a pull-up resistor mode, what I'm going to do is I'm going to grab from my 3-volt system over here. I'm going to attach it to one lead of my button. I'll do it on the top. Oh, sorry, I forgot to put the resistor in there, actually. I'm going to take my resistor, I'm going to take it from one lead, and then choose another lane over here from the top lead of my button, and I'm going to take my 3-volt power to that resistor, and then it comes through and taps there. Then I'm going to take my signal pin, I'm going to grab from the same top lead, and I'm going to put it inside a digital signal. So if I were to turn this on right now, what's going to happen is I'm going to take 3 volts out through this jumper wire, come down the rail into 3 volts here, come through my resistor, through the top lane of my button, and then into this lane to my digital 1 port. When I press the button, I need a way that I can bring this power back to ground so that we end up reading low. So I'm going to grab another lane of my button, and again, I could choose either side here. I'm going to attach it back to my common ground. So now when I press the button, 3 volts is coming out, going through this wire, going through my 10-volt or my 10,000 ohm resistor, and rather than going to my signal pin, it's always going to want to run back to ground. So my 3 volts is going to through this ground, back up my ground rail, back into this ground wire, and back into our common ground. So what's going to happen is this button is going to read true when it's not pressed, or high, and when I press it, it's going to read low. So let's head over to the computer and actually program that. First thing we have to do is we need to import board. We're also going to import time, and we're going to, from digital in out, or digital I/O, we're going to import digital in out, we're going to import direction, and we're going to import pull. Now it's time to actually initialize the button. So let's init the button. We'll make a button called button, and we'll say button is equal to digital in out and board.d1, because that's where we connected our button. We need to set the direction of the button, because digital in out obviously can make things in and outputs. So I'm going to say button dot direction with a lowercase d is equal to direction with an uppercase d dot input, because this is going to input into our device. Then we're also going to say button.pull, again with a lowercase, is equal to pull with a capital dot up, so that we know that this is a pull up button. Again, when you pull up buttons, it tends to make their sensor readings a little bit more reliable because their signal reading will always be high. So if there's signal noise, having a little bit of high signal will make that a little nicer. Let's actually read this now. So we'll say while true, we're going to say button underscore state is equal to button.value. So we'll assign a variable, and we'll call it with the current value. And for now, let's just print button underscore state, and then we'll add a small sleep at the end, maybe 10 milliseconds. The reason we want a really small sleep is because if you don't have a small sleep, what will happen is you start getting bouncing on your buttons or debouncing. When you push it, it's not actually going to read reliably because your CPU is running over so fast that it doesn't actually have time to read the electrical signals that are being sent out. So we will save this over to our board. Let's go ahead and plug this in. We'll save this to the code.py file on our CircuitPy drive. And now you'll notice that our button is currently reading true. When I go ahead and push this, our serial now starts reading false because it's being pressed. So when it's pushing, it's false. So let's actually do something a little more interesting with this, because this is typically not how we actually work with a button. Now I'll say if not button underscore state, we will print pressed. Else we won't do anything. So the only time we're going to print something is we're going to add in a certain point. And maybe we'll add in a quick counter here. We'll say counter is equal to 0, and we'll say print pressed, or actually let's say counter plus equals 1, and we'll say pressed counter times. So we can know how many times we've actually pushed that button. So if I save this over, I should have nothing printing, but as soon as I come over and I push this button, you can see that it will register over quite a few times. So if I press it once, it actually registers it several times. So if I push and hold it, I can just add up to that counter quite quickly over time. And that's it. Again, the main thing we want to say is if not button state. If we were to say if button state, this would be the same as saying if true. In this case, when it's not pressed, it's going to be reading high. Which is, in ours, being a pull up button. We don't want that. So I hope that helped you out with wiring up and programming up a button.